In the last lesson, we learned a little bit about our Milky Way Galaxy. In this final lesson, we'll consider our galactic neighborhood, some of the nearby galaxies, as well as the universe as a whole. First, to recap, we live in a spiral galaxy, and if we could get outside the galaxy at just the right orientation, we could take a picture like this. It's composed of a few 100 billion stars. Our sun is one of them, and scientists today now estimate that most of the stars in the Milky Way Galaxy probably have planets, so they would constitute solar systems like our own. We've learned that the sun has nearby neighbors. These are the stars that we see in the night sky. They're close enough to appear bright enough that we can detect them with our eyes. In this picture, then, we're just seeing the stars in our local solar neighborhood here when we look up at the night sky. However, when we look towards the center of the galaxy, we see the Milky Way Galaxy. And again, cameras can give us this rich detail, but to the naked eye, the Milky Way appears to be this kind of faint, fuzzy white band that runs across the sky. Now in this diagram, we see the local group of galaxies. The Milky Way is one of the galaxies in our local neighborhood, but there's another large galaxy. In fact, it's larger. It's called the Andromeda Galaxy. You'll notice over here, though, close to the Milky Way, outside of the Milky Way, are two small clusters of stars. They've got, several billion stars each. They are the Magellanic Clouds, right there. In the sky, they appear to be these splotches. To the naked eye, they're just sort of white, fuzzy patches. But again, the camera can collect more light. They are regions of star formation, so there's lots of gas and dust that are around to make new generations of stars. Here they are, again, pictures taken in Chile. Now let's turn our attention to our big neighbor, the Andromeda Galaxy. Now let's see if you can find the Andromeda Galaxy in this next picture. Sometimes it's referred to as M31 to astronomers, but can you find the Andromeda Galaxy? If you said that object, you were right. That's M31, the Andromeda Galaxy. If we just crop in, we can see the galaxy here. And here again, we see the Andromeda Galaxy. Cropped in a little bit more. Cropped in a little bit more. If you're looking to find the Andromeda Galaxy, if you can find Cassiopeia, this arrangement of stars here, that kind of pointy part of Cassiopeia sort of points to the Andromeda Galaxy. This is what the galaxy looks like with some good photography equipment and some telescopes. Beautiful. It's a large galaxy. And this will give you a sense of the scale relative to the size of the galaxies. So the Milky Way Galaxy is about 100,000 light years. It would mean light would take 100,000 years to get from one end to the other end of the Milky Way. Well, it takes light 2.5 million years to travel to the Andromeda Galaxy. You'll notice Andromeda is a bit bigger than the Milky Way, 140,000 light years wide. Now, if we could see with the naked eye all of the extent of the Andromeda Galaxy, it would appear to be a large structure in our night sky. In fact, about 6 times the diameter of our moon. However, we only see this sort of the core region of the galaxy. So it appears to be a small object in the night sky. Here's another sort of a Photoshop recreation of what Andromeda would look like if our eyes were good enough to detect the entire structure of the galaxy. That's how big it would be in the night sky. Now, in modern times, we have learned that our universe consists of billions and billions, hundreds of billions of galaxies. In fact, the famous Hubble telescope took this picture. They pointed it at a dark region of the sky, and they left the camera shutter open for a long period of time to collect as much light as possible, and this is what they got. Pretty much everything you see, every splotch of light in this picture, is a galaxy. The exceptions are these stars here. These are nearby stars in our own galaxy, but all the other splotches of light are other galaxies in just one tiny portion of the night sky. So our universe is huge, and it is packed full of lots and lots of galaxies, just like our own Milky Way Galaxy. To get a sense of the scale of our universe, imagine this cube would be the size of a typical school classroom. And let's say then that the classroom was the extent of the entire universe. Well, one little dust particle floating in the air in that classroom would be an entire galaxy. So our Milky Way Galaxy then would be a tiny little dust particle. And of course, one room would have billions and billions of dust particles. Scientists estimate hundreds of billions of galaxies in our universe. Again, if the universe was the size of a classroom, our galaxy would be a tiny dust particle. Now, we humans often ponder, as we look at the beauty of nature and our cosmos, what does it all mean? And is there anybody else out there? What does it mean if we're the only ones in the universe? What does it mean if we're not? And we'll be learning in this course that science raises the challenging possibility that we live in a universe not made for us. In this view, there is no meaning that is built into the universe. Consequently, we must construct our own significance. And again, as the noted astronomer Carl Sagan put it, we make our world significant by the courage of our questions and the depth of our answers. But should we find other intelligent beings in the universe, it will be a profound reminder of this awesome fact, that we, all of us, are a way for the cosmos to know itself.